Hello. Thank you for your interest in our Simulink program. Meet our robot, the Fire and Rescue Emergency Defender, also known as Fred. Fred was built to efficiently handle all tasks that Crossfire requires. He does this by using 4 main physical components. Each of these features required a piece of software to be written in order to work as intended. To ensure a successful rescue of Manny, Fred uses a mechanically elevated platform that operates similarly to a forklift. The platform slides under Manny, then lifts him up using a small motor. Throughout the season, our team used the waterfall development method to create and maintain our program. This process can be shown in the creation of the subsystem that lifts Manny. After identifying a task, the programmer should design a possible solution. The flowchart shown illustrates this thought process. The chart was then used as a template to write a MATLAB function that determines the values to send to the motor based on given inputs. The binary values sent to the MATLAB function are taken from the upper and lower left triggers on the back of the controller. This control scheme mimics the direction of travel, helping robot operation feel more natural to the driver. Currently shown is the process of simulating forklift operation within Simulink. The values in the display boxes represent those sent to Fred's motors. Next up after the forklift is the drive subsystem. This subsystem is responsible for Fred's movement within the playing field. It uses 2 large motors mounted on opposite sides of the robot, each attached to its own wheel. Motor speed and direction are determined by the y-axis positions of the left and right joysticks. Each of the joysticks control motors on the corresponding sides of the robot. This control style was chosen because of the precision required for maneuvering around the field. These videos show the functionality of the subsystem. On the left is a portion of the program's main screen containing the drive subsystem, along with a few output displays. The video on the right shows Fred using the drive subsystem. Fred's gripper subsystem is responsible for the safe relocation of chemical drums. It is attached to the forklift to allow for vertical movement, and its 2 individual claws allow for up to 2 drums to be carried at once. Each claw uses 1 servo. The inputs that determine the position of the servos are taken from the left and right buttons on controller channel 8. The motion is set to a toggle. Once again, you can see the Simulink program alongside the physical robot. The final individual subsystem is the water launcher. This subsystem uses the rack and pinion to create tension by pulling back rubber bands. During rotation, the tension is released and water is propelled forward. The motor's rotation is triggered by holding the upper right trigger on the back of the controller. This button was chosen because of its similar use in modern video games. Because many of our drivers are avid gamers, the choice was easily accepted. This is the launcher in action. These clips are of both the Simulink model and the robot launching water. So thanks again for taking the time to learn about our development process and Simulink model. We'll see you on game day!